In this video, I'm going to go over how to calculate the efficiency of heating and cooling equipment. So we'll go over what SEER means and how to calculate it, what HSPF means, how it calculates it, and then finally AFUE and COB. Okay, lots of acronyms. So as a review, air source heat pump, we are pulling heat from in this case, we are pulling heat from inside and dumping heat outside. Okay, so this would be in cooling mode. So if I want to know how efficient it is, it's not really how efficient it is, but how sort of effective it is at cooling. And we use this as, it's not technically efficiency because you're not converting the energy from one form to another because you're just using electricity to move the heat. But here's how you rate we'll just call it efficiency of an air source heat pump. Okay, so in cooling mode, it's SEER, Seasonal Energy Efficiency Ratio. This is something I expect you to know. So the SEER is actually pretty easy in terms of the formula. You take the heat removed during the cooling season in BTUs and divide that by the electricity used in watt hours. And that's it. Pretty straightforward. Energy Star SEER rating is, Energy Star is sort of the minimum level of efficiency through the EPA. That's considered an efficient equipment. So SEER 15 is pretty common. The highest you get is in the high 20s. That would be like your mini splits. And so keep in mind that the SEER rating is based under laboratory conditions, and so it's not always going to operate at that efficiency. And if you want to really dig into the details, you would look at the spec sheet, and you would have to see, because it operates at different efficiencies at different temperatures. This would be under pretty optimal conditions. It's rated SEER rating. You can find the spec sheet and go to the table, and you see the energy efficiency ratio table, and so it'll tell the EER is if it's this cold outside, how efficient is, what's the SEER going to be, or how efficient is going to be operating, right? Or how many BTUs per hour can it remove for watt hours that you use. So remember, we've talked about this before, as it gets really hot outside with an air source heat pump, you're pulling heat from the air. So if it's, or you're dumping heat, you're dumping heat into the air when you're in cooling mode. So if it's really hot outside, it's more difficult to dump your heat into that air. So the EER is going to drop as the air temperature increases outside and you're trying to cool. So it's pretty easy to remember. It gets hot outside, it's hard to cool with that air. Okay, so your EER is going to drop. For a heat pump, remember, you can go in either direction, right? So here you have your condensation is occurring inside, so your condenser coils are inside in this image. So the efficiency, quote-unquote efficiency rating for heating is called HSPF, or Heating Season Performance Factor, and it's just like SEER, except it's heat of BTU, or the heat added during the heating season in BTUs divided by the watt hours. So remember, SEER is the heat removed during the cooling season divided by watt hours. This is the heat added during the heating season in BTUs divided by watt hours. Energy Star HSPF, it's actually a lot lower. That is because if you think about indoor air temperature, let's say you have a base temperature of 65, right? In a really, really, really hot climate, maybe you're at 100 degrees, so you have a 35-degree delta between your base temperature and your highest temperature, right? So 100 degrees minus 65 degrees is 35 degrees of difference. Think of a really, really cold place like, northern Alaska, northern Canada. You might have -10, right? And so remember, on a really, really hot climate, your delta for cooling is about 35. In a really, really cold climate, your delta for heating could be 85, right? It could be -20. And you want to get it up to 65, so that's a huge, huge delta. And so that's why, generally speaking, your HSPF ratings are lower, because you're going to be under conditions where it's harder to grab heat from the outside. Okay, so just like you you can have this varying EER at different temperatures. You have a varying what's called an HPF, and again you would go to the spec sheet of the heat pump, and again it's intuitive, right? If it's really cold outside, you're trying to pull heat from that outside air, that HPF is going to drop. On a nice like 50 degree, 60 degree day, and you just need a little bit of heating in your inside of your house, those will operate at optimal efficiency. It's really easy to pull heat from air that is that temperature. Okay, so this will vary. And you can use this as a formula, so we can actually figure out, just like any other 3-variable equation, we can figure out the third from the other two, right? So let's just do a sample problem here. If I have a heat pump that removes 70 MMBTUs of heat over the cooling season, and it uses 4,800 kilowatt hours, what is the SEER, okay, for that season? So remember, it's heat removed, 70 MMBTU, so heat removed in BTUs, so we just need to convert that to BTUs, and then we need to convert this to watt hours. Be really careful. We need to convert that to watt hours, right? So it's pretty easy. 70 million BTUs divided by 4.8 million watt hours, and we end up 14.6 here. Okay, so if you do this right, you're going to end, if you get a number like 40 or 1, you probably did something wrong. It's usually going to be in this 10 to 15, maybe a little bit higher range. Okay, so we can do the same thing with HSPF. So let's say we have a heat pump that has an HSPF of 5. Okay, we use 1,000 kilowatt hours of electricity. How many BTUs do you get out of the heat pump? Okay, so again, it's only 3 variables. We have 1,000 kilowatt hours. There's our electricity used. We convert that to watt hours. We have our HSPF is 5, so we need to find out this heat added. So you just do a little bit of rearrangement for this, right? Very basic algebra. So if you do that, what you end up doing is you take the HSPF times the watt hours used, and you end up with 5 million BTUs or 5 MMBTU. That's how many BTUs you would have provided in heating, assuming an HSPF of 5 and 1,000 kilowatt hours of electricity. Okay, so it's the math here is not hard. You just have to kind of know what you're talking about here. Okay. So the two other efficiency metrics that you should know, number one is the annual fuel utilization efficiency, or AFUE. This is really common for furnaces. And then COP, or coefficient of performance, which is really common for chillers. They'll use it for other things too, but primarily chillers. So AFUE is really just efficiency over the course of a season. That's all it is, right? So for example, and this is something you should be able to do from previous lessons, what's the AFUE if you added 47,150,000 BTUs and you used 500 CCFs of natural gas during the whole season, right? So you burned 500 CCFs, this is the heat you got out of it. It's a basic efficiency problem, right? So it's going to be your output over your input. That's it. So you convert, just make sure that everything's converted to BTUs. So we have CCFs, BTUs. So we convert our CCFs to BTUs, divide, and we end up with 92% AFUE. That's it. So it's just an efficiency, but it's over the course of a season. Excuse me, not at a given time. COP, on the other hand, this is a little bit different. This is unitless, and it's nice. It's very intuitive because it's just the energy. It's basically what you're getting out of it compared to what you put into it. Okay, so again, this is often used for chillers. So you want a COP of greater than 1. I mean, you see, chillers they should be operating at 2 or even 3 COP. You can even get upwards of 4 and 5 for really, really high efficiency chillers. And in order to do this, you just need to make sure that the units are the same, because it is this metric COP has no unit, which means you have to have one unit divided by the other unit. Okay, so we'll do an example here. I think it'll make sense. All right, so if I use 1,000 kilowatt hours to remove 8,530,000 BTUs with a chiller, what's the COP? Okay, so I need, really, just remember, you just need to convert these to the same unit. Technically, you could convert BTUs to kilowatt hours. Makes a little more sense. just intuitively to convert kilowatt hours to BTUs. So let's do that. So we have 1,000 kilowatt hours is equal to 3,412,000 BTUs. Okay, so that's how much we used. That's the energy we used, right? So we used 1,000 kilowatt hours. This is what we pulled out, which means we pulled out more, which has a COP of greater than 1. So we just divide the one by the other. 8,530,000 divided by 3,412,000, and we get 2.5. And so what that means is, with the COP of 2.5, just means we're getting 2.5 units of energy removed for every unit of energy that we use, and that's it. So it's pretty easy to understand what COP is. You just have to remember what it is. Okay, and that's it for the efficiency. So now you know what SEER means, how you calculate it, what HSPF means and how you calculate it, and also AFUE and COP.